All right, in this video, we're going to pick up where we left off last time with suggested homework problems with 8.2. Starting with number 43, we'll start with the definite integral problems now. So 43 says integral of 0 to 3, x e to the x over 2 dx. Let's recall our fundamental theorem of calculus that says that the integral from a to b of f of x dx is equal to the antiderivative of f at b minus the antiderivative of f at a, or we can write that as antiderivative of f evaluated from a to b, like this. I'm going to use that. I'm just going to find the antiderivative without the limits, and then I'll use the fundamental theorem of calculus at the end. So x e to the x over 2 dx with u equal to x and dv equal to e to the x over 2 dx. du will be dx and v will be 2e to the x over 2. So this is going to be integral of x e to the x over 2 dx is equal to uv minus the integral of v du, integral x e to the x over 2 dx is equal to 2x e to the x over 2 minus 2 integral e to the x over 2 dx is integral x e to the x over 2 dx is equal to 2x e to the x over 2 minus 4 e to the x over 2. And I'm not going to put a plus c on the end because this is going to become a definite integral. 0 to 3, x e to the x over 2 dx is equal to, and then this will be my capital F of x from my formula here that I'm going to evaluate from 0 to 3 is going to be equal to 2 times 3 e to the 3 halves minus 4 e to the 3 halves minus, and I'll put 0 in, 0 minus 4 e to the 0. So that's going to be 6 e to the 3 halves minus 4 e to the 3 halves minus a negative 4. And that's going to be 2e to the 3 halves plus 4. I'll approximate that for you. 2e to the 3 halves plus 4 is approximately 12.963. So again, that was number 43. Let's look now at number 49. '49 says integral 0 to 1 of e to the x sine of x dx. And I'll find integral e to the x sine of x dx. Going to call this I. This is just a technique. When I have exponential and trig functions mixed together like this, I think it's going to wrap around on itself, and I'll use the variable I to help me keep things simpler here. But u is going to be sine of x, and dv will be e to the x dx. du will be cosine of x dx. v will be e to the x. So I is going to be equal to uv minus the integral of v du. And then we have a new u that will be cosine of x. dv will stay e to the x dx. du will be a negative sine of x dx. v will be e to the x. So I will be equal to e to the x sine of x minus uv cosine of x minus the integral v du. So this is I is equal to e to the x sine of x minus e to the x cosine of x minus integral e to the x sine of x dx. And this is I is equal to e to the x sine of x minus e to the x cosine of x minus I, so 2I is equal to e to the x sine x minus e to the x cosine of x. I is equal to 1/2 e to the x times sine x minus cosine of x. And so now evaluate I from 0 to 1 is 1/2 e to the x sine of x minus cosine of x 0 to 1. So that's going to be 0 to 1 e to the x sine x dx is equal to a 1/2 e times sine of 1 minus cosine of 1 minus 1/2 times 1 times 0 minus 1. So 0 to 1 e to the x sine x dx is equal to 1/2 of e sine 1 minus e cosine of 1 plus 1, because -1 times -1 is going to be +1. So, and 1/2 comes out of everything. So this is 0.5 times e sine of 1 minus e cosine of 1 plus 1 is approximately 0.909. So look now at number 51. 51 says integral of x arc secant of x dx. So my inverse trig function has to be my u. Let's go ahead and here write 51. And let's not forget my limits here. dv has to be x dx. So du is 1x squared minus 1 dx. V is 1/2 x squared. So this is integral u dv. So this is going to be uv minus integral v du is equal to 1/2 x squared arc secant of x minus 1/2 x squared over x root x squared minus 1 dx, and x's cancel. So x arc secant x dx equals 1/2 x squared arc secant of x minus, I need a 2, and a 1/2 here to balance it out. I'm going to do a u substitution here of u is equal to x squared minus 1. Du is 2x dx. So minus 1/4 integral of u to the negative 1/2 du. X arc secant x dx is equal to 1/2 x squared arc secant of x minus 1/4 u to the 1/2 times 2. So my integral x arc secant of x dx is equal to 1/2 x squared arc secant of x minus 1/2, and then u was x squared minus 1 to the 1/2 power. So there's my antiderivative. I'll evaluate that from 2 to 4 now. X arc secant of x dx is equal to 1/2 x squared arc secant of x minus 1/2 square root of x squared minus 1, evaluated from 2 to 4, is equal to, stick 4 in there, half of 16 is 8. Arc secant of 4 minus 16 minus 1 is 15, minus half of 4 is 2. Arc secant of 2 minus 4 minus 1 is 3. So this is 8 arc cosine of 1/4 minus 2 arc cosine of 1/2 minus root 15 over 2 plus root 3 over 2. And arc cosine of 1/2 is pi over 3. So this is exactly 8 arc cosine of 1/4, which is irrational, is something that we'll have to estimate with a calculator, minus 2 pi over 3 minus root 15 over 2 plus root 3 over 2. Let's approximate this now. 8 arc cosine of 1/4 minus 2 pi over 3 minus root 15 over 2 plus root 3 over 2. And that's approximately 7.380. Look at a problem where we need a double, we'll need to use substitution, and then we'll need to do integration by parts. So because we'll be using the letter U later in the problem for integration by parts, I'll have my substitution as the letter T. So T is equal to the square root of x, T squared is equal to x. 2t dt is equal to dx. Integral of sine of t times 2t dt will turn into 2 integral t sine of t dt. which we'll set up with integration by parts with u is equal to t and dv is equal to sine of t dt. Du is equal to dt and v is equal to a negative cosine of t. So 2 times uv minus the integral of v du, so negative 2t cosine of t plus 2 integral cosine of t dt is a negative 2t cosine of t plus 2 sine of t plus c, and t is equal to the square root of x, and negative 2 root x cosine root x plus 2 sine root x plus c. All right, let's look at number 67. Going to start with the integral of x cubed over root 4 plus x squared dx, and we're told to let dv be equal to x over root 4 plus x squared dx. The idea here is that I could multiply by 2 here and make a u to the n du situation. So when I integrate both sides here, 2v is equal to u to the 1/2 times 2. 2's will cancel. V is equal to 4 plus x squared to the 1/2, or v is equal to the square root of 4 plus x squared. U is equal to x squared is what was left over. Du is equal to 2x dx. So uv 4 plus x squared to the 1/2 minus integral of v du 2x root 4 plus x squared dx. I'm going to rearrange just a tad here. 4 plus x squared to the 1/2 times x dx. If I set up my u substitution as 4 plus x squared, du would be 2x dx. I'll have a 2 and I'll have a 1/2 there. So x squared 4 plus x squared to the 1/2 minus 4 plus x squared raised to the 3/2 times 2/3. And that will be plus c. And let's do a little bit of factoring here. 1/3 4 plus x squared to the 1/2 will come out 3x squared minus 2 times 4 plus x squared plus c. That is root 4 plus x squared over 3 times 3x squared minus 8 minus 2x squared plus c is root 4 plus x squared over 3 times x squared minus 8 plus c. Now let's see if we can get the same answer with a different technique in part B. So again, starting with integral of x cubed over root 4 plus x squared dx. This time we're going to let u be equal to 4 plus x squared. And we'll say x squared is equal to u minus 4. And I'll have x is equal to u minus 4 to the 1/2 power. Dx is equal to 1/2 u minus 4 to the negative 1/2 times du. And x cubed will be u minus 4 to the 3/2 power. And then this will be u to the 1/2 power times dx will be 1/2 u minus 4 to the negative 1/2 power du. So 1/2 will come out front, and then subtract 1/2 from 3/2 will give me 2/2, or just 1 du, u to the 1/2. So that's 1/2 of u to the 1/2 minus 4u to the negative 1/2 du, which is equal to 1/2 u to the 3/2 times 2/3 minus 1/2 of 4 is 2, u to the 1/2 times 2 plus c will give me 1/3. U is 4 plus x squared to the 3/2 minus 4 times 4 plus x squared to the 1/2 plus c. So pull out our 4 plus x squared to the 1/2 and our denominator of 3, just like before. And this will be 4 plus x squared to the first minus 12 plus c is square root of 4 plus x squared over 3 times x squared minus 8 plus c, and we get the same answer both ways. All right. Let's look now at number 79. '79 asks us to find the integral x to the 5th ln of x dx. And we are to, it wants us to use a formula. Let's not use a formula. I don't think that that's usually the way that your teacher has you do it. We can do it pretty easily without the formula here. So my log piece has to be my u, my dv has to be everything else that's left, and du is 1 over x dx, and v is equal to 5x to the 4th. So this is going to be uv minus the integral of v du. So this is 5x to the 4th ln of x minus 5 integral of x to the 3rd dx. Be 5x to the 4th ln of x minus 5x to the 4th over 4 plus c. Let's see, u v minus the integral Why did I differentiate there? X to the 6 over 6. Getting tired, sorry. UV minus the integral of v du. That's better. That's your answer. Now, if you want to do some factoring, you can do that. 1 over 36, x to the 6th times 6 ln of x minus 1 plus c. That's how it would look with the formula. They'd have it like this, and it would come out to be the same thing. All right, let's find a centroid. 87. So y equals ln of x, y equals 0, x equals e. Take a look at what that graph would look like. Be something like this. Then at e, we'd have 1. This point here is E0. This is 1, 0. We're talking about this region right here. So first, let's find that area, 0 to 1, sorry, 1 to E of ln of x dx. So we have u is equal to ln of x, du is equal to 1 over x, dx, dv is dx, v is x. So we have uv minus v du integral. And so this is equal to x ln of x minus x. So we're going to evaluate that. From 1 to e is e times 1 minus e minus 0 minus 1 is e minus e is 0 minus a negative 1 is 1. So the area under the curve here is 1. Let's find the volume of the region generated by revolving around the x-axis. So that's going to be a disk method, pi r squared, and that's going to be u is ln of x squared, dv is dx, du is 2 ln of x times 1 over x, and v is equal to x, pi u v x ln of x squared. This is from 1 to e. Minus, don't forget your multiplier of pi, 1 to e v du. The x, the 1 over x cancel each other out. And so you have pi times e times ln of e is 1 squared minus 1 times ln of 1 is 0 squared minus 2 pi times 1 to e of ln of x dx is right up there. We just found out that that was 1. So no need to do all those steps again from part A. It says pi times e minus nothing minus 2 pi is pi times e minus 2. Part B. So look at C. C says the volume by revolving around the y-axis. So this will be shell method. 2 pi 1 to e of, and then the distance to my rectangle will be x, and my height will be ln of x. So x ln of x dx, and u will be ln of x, and dv will be x dx. Du will be 1 over x dx. V will be 1/2 x squared. 2 pi times uv 1/2 x squared ln of x from 1 to e, and this will cancel, minus 2 pi 1 to e v du. So that's going to be 1/2 x dx. So those will cancel. This will be pi times e squared ln of e minus 1 squared times ln of 1, which is 0, minus pi times 1/2 x squared from 1 to e. So this is pi e squared minus pi times e squared over 2 minus 1/2 is going to be pi e squared over 2 plus pi over 2, or pi times e squared plus 1 over 2. And then D, the centroid of the region. So we're going to need our M, which is going to be 0 to 1 of ln of x dx. Sorry, 1 to e. Keep saying 0 to 1 because I'm thinking of the ln values. So 1 to e of ln of x dx, which we already found out to be 1. Our m sub x will be 1 to e of ln of x over 2 times ln of x dx. So this is equal to 1 to e 1/2 ln of x squared dx. So let me come back up here to b. So I had pi in front of this. So if I fix this to say 2 m of x divided by pi is equal to pi 1 to e ln of x squared dx. I have my answer from part B was that this is pi, I need to do this to both sides of the equation. So 2 pi mx, there we go. So 2 and then multiply pi on both sides. This was pi of e minus 2. So 2 pi mx is equal to pi e minus 2. Pi's go away. Mx is e minus 2 over 2. My is going to be 1 to e of x ln of x dx. That's really close to what I had up here. I just had 2 pi in front of it. So 2 pi my is equal to 2 pi 1 to e x ln of x dx, which was equal to pi e squared plus 1 over 2. So 2 pi my is equal to pi e squared plus 1 over 2. Pi's will come out. My is equal to e squared plus 1 over 4. Because my m is 1, my mx here is my y bar, and my my is my x bar. So I have my centroid here, x bar, y bar of e squared plus 1 over 4 and e minus 2 over 2. And let me approximate that for you here, that e squared plus 1 divided by 4 is 2.097, and e minus 2 divided by 2 is approximately 0.359. And that's it for this video and for this section. We'll come back next time and we'll talk about 8.3 trigonometric intervals. See you for the next video.